Sound waves carry energy that can be used to do work, like forcing the eardrum to vibrate. In an extreme case, such as a sonic boom, the energy can be sufficient to cause damage to windows and buildings. The amount of energy transported per second by a sound wave is called the power of the wave and is measured in SI units of joules per second, or watts. When a sound wave leaves a source, such as the loudspeaker seen here, the power spreads out and passes through imaginary surfaces that have increasingly larger areas. For instance, the same sound power passes through the surfaces labeled 1 and 2 in the drawing. However, the power is spread out over a greater area in surface 2. We will bring together the ideas of sound power and the area through which the power passes, and, in the process, will formulate the concept of sound intensity. The idea of wave intensity is not confined to sound waves. It will recur, for example, when we discuss electromagnetic waves. The sound intensity I is defined as the sound power P that passes perpendicularly through a surface divided by the area of that surface, or I equals P divided by A. The unit of sound intensity is power per unit area, or watts per meter squared. If a source emits sound uniformly in all directions, the intensity depends on the distance in a simple way. Here, we see such a source at the center of an imaginary sphere. For clarity, only a hemisphere is shown. The initial radius of the sphere is r. Since all the radiated power, P, passes through the spherical surface of area A equals 4 pi r squared, the intensity at a distance r from the source is I equals P divided by 4 pi r squared. From this, we see that the intensity of a source that radiates sound uniformly in all directions varies as 1 over r squared. In other words, the intensity decreases as the square of the distance from the source. For example, if the distance increases by a factor of 2, the sound intensity decreases by a factor of 2 squared, which is equal to 4. In summary, power is the amount of energy transported per second by a sound wave. The intensity is the sound power P that passes perpendicularly through a surface divided by the area A of that surface, or I equals P divided by A. The SI unit for intensity is the watt per meter squared. Finally, the intensity at distance r from a spherically symmetric source of power P is I equals P divided by 4 pi r squared, from which we see that the intensity decreases as the square of the distance from the source.